Alright guys, welcome back. Here's a little bit of help for you guys on your Delta Math. We're on to Unit 8, which is trigonometry, which is the last thing that we were going over in class before everything had the shutdown happening, right? So that's working with sine, cosine, or tangent. The first thing I want you to do is, on these problems, only do the problems that have sine, cosine, or tangent. If it doesn't have one of those, skip it. You don't want to work with secant, cosecant, or cotangent because we didn't go over those. Make sure you're only looking at these three, sine, cosine, and tangent there. Just a quick thing, remember sine is opposite over hypotenuse, right? Cosine adjacent over hypotenuse, and tangent opposite over adjacent. So we have that SOHCAHTOA to help us remember what we need to do. The second thing, if you look here in the middle of this screen, I have the special right triangles, right? We have the 30, 60, 90. We have the 45, 45, 90 triangle right there, because that's what's going to help us when we go through and we find the angle that satisfies these equations. So for these problems, we're going to do two of them because I thought I should try to do as many as I can, but we really are just trying to solve for x, which in our class, when we went through and did it, we wrote theta there. But in this case, they have x. It's okay. It's just a variable. We're going to try to find that. So the first thing that we're going to do, just like we do in all of our problems, we're going to start over here on this first example. 2 sine of x minus 1 equals 0. We're trying to figure out what angle is going to satisfy this equation. The first thing we do is we want to get sine by itself. So we go plus 1, we get 2 sine of x equals 1, divided by 2 now, right? And we get that sine of some angle x, is equal to 1/2. It was at this point when we need to go through a couple of different steps. The first step is what I had you guys do was draw an XY axis, because this is going to tell us where on the unit circle we know sine of x is going to be 1/2. We're actually going to draw on the triangles. The first thing that we do, though, is we notice sine is positive, right? So we need to figure out in which two quadrants are we going to draw this. So that's when we did the all students take calculus, meaning that all of the trig functions are positive in quadrant 1, sine is positive in quadrant 2, tangent is positive in quadrant 3, cosine is positive in quadrant 4. So if we look at this, we have sine of x equals positive 1/2. That means we're in quadrants 1 and 2 because that's where sine has to be positive. So the first thing we want to do there is let's just draw our two triangles here in quadrants 1 and quadrants 2. That's the first step, because it's going to tell us that we need two answers, right? We're not just going to have one answer. The second thing, we're trying to figure out how big is this reference angle here on those two triangles. That's where looking at sine of x equals 1/2 is going to tell us a bunch of information. The first thing is, remind yourself, sine is opposite over hypotenuse, right? So that has to be opposite over hypotenuse right there. Why that helps us is because now we can determine which of these two right triangles is going to give us sine that's opposite over hypotenuse is 1/2. The first thing, it cannot be the 45-45 right triangle, because that has a square root of 2. We need just the regular 2 for our hypotenuse. So that means we look back, we look at the 30, 60, 90. Again, sine is opposite over hypotenuse. We can check either the 60-degree angle or the 30-degree angle. If we did 60 real quick, opposite from the 60 is root 3. The hypotenuse is 2. So that means sine of 60 is root 3 over 2. We don't want that. We want 1 over 2. So if we go back, look at 30. Opposite the 30 is 1. The hypotenuse is 2. That gives us 1 over 2, which is exactly what we want. that angle has to be 30, which means in our triangles right here, our reference angle is going to be 30 degrees. Now, how that helps us is because we're answering these questions here, and I believe we're answering these in radians, because on the question it says between 0 is less than or equal to x is less than or equal to 2 pi, which means we need to answer in radians. What that means is we're not only working with 30-degree angles, we want to look at that in what radians are. If you don't remember, 30 degrees is the same thing as pi over 6 in radians. Just so you guys have something to help you, 60 degrees is pi over 3, 45 degrees is pi over 4. So you have those for if you have trouble with some of the other questions. But we know we're 30 degrees, which means that instead of writing 30 here, let's replace this with pi over 6, because we are working in radians. That's what we want our answers in. And really, all that's left is we just need to say what those angles are now in radians. So we have this first angle. Let me try to draw it. That opens up, and it's in the first quadrant. So the question is, how big is that angle? If it opens up and it just stops right there in the first quadrant, it's exactly pi over 6 degrees. So one of our answers is x equals pi over 6. The second angle, right, now we open up all the way, we come right here. We almost get halfway around the circle, but that's not halfway, right? If you remember, halfway around our circle is pi, right? Now, what we need to do is figure out how much is it if we go almost all the way, but we stop short pi over 6 degrees. So that is when we would set up, instead of writing this as pi over here, since we have denominators of 6, it's the same as 6 pi over 6, which means that opens up to 5 pi over 6. If you don't know why, it's because if all the way around is 6 pi over 6, but we subtract this pi over 6 minus pi over 6 equals 5 pi over 6. So those would be the two angles that give you sine is equal to positive 1/2. Pi over 6 and 6 pi over 6. Now, we're going to go through the process again over here for tangent. This is so you guys can see one that's not exactly the same, and so you guys can see a couple different examples. The second question here, let me go over here. Our second question is 3 tangent of x equals the square root of 3. Again, the first step, get tangent by itself, so we divide by 3. We're going to go through this one a little bit quicker. So we have tangent of x equals root 3 over 3. Again, it's at this point right here where we want to set up our coordinates grid so we can figure out where we need to draw our triangles. Again, it's all students take calculus. Again, in this case, we have tangent. It's positive, which means we're only going to be drawing in the first quadrant because that's where all of them are positive. And then we're also going to draw in the third quadrant because that's where tangent is positive. Make sure when you're doing everything in this unit, you're connecting with the x-axis. You're not coming over and connecting with the y-axis. So we know we're in the first and the third quadrant. The last thing that we need to do to help us out here is figure out 30, 60, 90 triangle, 45, 45, 90 triangle, because we need to find that reference angle. Now, this is where we have to think a little bit, right? Tangent is opposite over adjacent. Now, clearly, we're not working with the 45, 45, 90 right triangle again because it has the square root of 2. We're looking at a square root of 3. So we want the 30, 60, 90. So we look at that, and now we just need to figure out, is it 30 degrees or is it 60 degrees? So let's start with checking 60 degrees again. Again, if we did 60, opposite over adjacent, opposite is root 3. Adjacent is 1. That's root 3 over 1. root 3 over 1 is not the same as root 3 over 3, which means that angle is not 60 degrees. Since that angle is not 60 degrees, that means it has to, again, be 30 degrees. Sorry it worked out like that. But that's because it's 1 over root 3. Opposite 30 is 1, adjacent is root 3, but if you remember, that's the same as root 3 over 3. If you end up doing 45, 45, 90, you get 1 over root 2. That's the same as root 2 over 2, just so you have that as well. But what we know is that angle is, again, 30 degrees. So we would come in here and write 30 degrees. But, again, we're not working in degrees. We want radians, so we're going to use pi over 6 in both of these. The last thing, again, is to figure out how big those angles are. Now, something that we did in class was we always wrote the 0, pi, over here is pi, all the way around is 2 pi, because it's going to help us find the angle in radians. Again, since it's out of 6, we're going to say 0 pi out of 6, 6 pi out of 6. If we went all the way around, this would be 12 pi out of 6. We just need to find those two angles. So this one in the first quadrant, again, it opens up, it stops in the first quadrant, which means that angle, x, is pi over 6. For this one in the third quadrant, now we go all the way around. We get halfway around, which is 6 pi over 6, but then, whoops, we go a little bit further. So we're doing 6 pi over 6 plus pi over 6 more, which is 7 pi over 6. And those would be your two angles that give you tangent is root 3 over 3. Those are a couple of questions to help you guys out as you go through these problems. I'm sorry they both ended up being the 30-degree angles. The only thing that's different is if it's a 60-degree angle, instead your reference angles will be pi over 3. And all of this, instead of being 0 pi over 6, 6 pi over 6 would be 0 pi out of 3, 3 pi out of 3, 6 pi out of 3. Right? That's the only difference that we have there for the different angles. Hopefully those two questions kind of help you out. If you have any other questions, let me know. Send me an email. Stay well, you guys.